to turn these observations into a physical law, I want to try to combine them together. And I can do that very neatly with a one final observation that I want to make, which is what happens if my velocity just happens not to be exactly along x, y, or z. So my final observation, which can also be derived relativistically or measured in the experiments, either way you want to do that, is that if you're not moving directly along one of the coordinate directions, but if your velocity actually has components, an x component in the I hat direction, y component in the j hat direction, and a z component, v sub z, in the k hat direction, if you happen to have a velocity along those lines, you can actually decompose the velocity into each of these different components, as I've shown you here, and simply add up the result. So you can, if that's the case, you can simply break into components and add. And if you do that, what you find, and this it can be confirmed in experiments, is that the final force, regardless of whether you're actually moving along exactly x, y, or z, right, you can still write down the final force, and it's going to end up equaling minus q times the velocity in the y direction times our favorite combinations of constants, mu naught I over 2 pi r. But this contribution, of course, is in the x direction, so that's the I hat component. And then you will have the next contribution, which will come in with a plus sign, which will be the charge, q, times its velocity in the x direction, times my favorite constants, mu naught I over 2 pi r, having to do with the wire, apparently. This then gives me the j hat component, and there's never, as we saw in all three cases, any z hat component that's coming in. Now, with this as my final result for the force of any particle traveling through this point at a distance r from the wire, there's now some general notes or observations that I would like to make about the physics of what seems to be going on here. The first thing to notice, of course, is that the force is always here proportional to, so the force is always proportional to the amount of charge that's moving. That's sensible, that makes sense. It's also proportional to the velocities. I think that's pretty clear here. So that makes me think that there should be some law here that F is equal somehow to Q times the velocity, right? Then somehow times something, right? I'm not sure what this something is, but it certainly is something that's due to the wire, right? That's where all these other things are coming in. And it has something to do with my location in space. The next thing I notice is that I'm going to need some special kind of times here, right, or product. It's a special product. It's some kind of vector product because I'm, using my velocity v, which is a vector, and I'm getting actually a vector for my answer for f. So I need a special vector product that gives a vector answer. So we might start to ask ourselves, what kind of vector product does that? And the other final hint you'll notice is that, and we saw this over here, right? Look at my picture. When we think about the directions of the forces that I'm getting, you'll notice that the force always seems to be at a perfect right angle with respect to the velocity. So the third thing to notice is that this product is always perpendicular to the velocity. So I've got those three very interesting ingredients there. So this then leads me to wonder, right? What kind of product does this sound like? This it gives a vector. It's always perpendicular. It's some kind of vector product. It's not the dot product. The dot product always gives us a scalar answer. This is giving us a vector answer. So it kind of sounds like the other classic type of product, which is known to give perpendicular answers. Perhaps this is actually the cross product that is involved. So we're beginning to wonder then, is it that this force is given by Q times V, right, cross with something? But this something, right, if we want to think about action at a distance again, right, this something here, I'll call it B for now, for reasons that will become clear. This something, if I'm not going to have action at a distance, right? Right now, the way I've written all my laws and my formulas, it's kind of like when we first had Coulomb's law, right? I've written it out in a form here that looks a little bit like action at a distance is involved again, right? Somehow my charge moving at a distance r from my wire is feeling this mysterious influence due to the wire. I know it's coming from the wire because it involves the current in the wire, right? That's creating this force on it, but across some distance. Well, we've been through this with the electric field before. We really reject this notion of action at a distance. So there must be some sort of property of the space that this particle is traveling through, a property of space at this location r, right, which is capturing whatever influences the wire is creating in the space around it, but it is the particle is somehow responding to a special property of space at its particular location. So here I could even emphasize it this way. Again, it looks like some kind of a field or something. It's some new property of the point R. Of the point R. So it's some new property of the point R. It's a new field. Right? This is definitely not the electric field, because the electric field, of course, creates a force we know is just charge times whatever that property of space is, Q times the electric field. The velocity doesn't enter into it, but in this case, very clearly, we are getting different answers here for the force. Even its direction is different depending upon what the velocity is. So this new field somehow couples into the velocity of the particle. So it's a new property of point R. It's a new field. We need a name for this, and this is actually what is known as the magnetic field. For reasons we'll see later, it's associated with the common phenomena of magnetism. So this seems to be where we're going with this. Now, before we continue, and before we can really mathematically verify that this is indeed a cross product, what we're going to do, because right now this is just a conjecture that I can do this mathematically, first we're going to have to review the properties of the cross product to make sure that this cross product form actually is consistent with the observations that we have so far.